Yeah, what up, guys? Learning from home. So, over spring break, I made this for my wife. Like, she wanted to read some classic bedtime stories to our kids, our grandkids, even. And so, this is Peter Rabbit. So, this is kind of some. Just want to show you this for a second. Woo! And then we'll jump over to 10.1 Solving in Exponential Form. Home study. Here we go. This is something I edited too. So let's see how well I did. Story time with Grandmama. Zoom in on the fireplace, dog, and rabbits.
Hello everyone. This is story time with Grandmama. Gather round, children. Here I want to introduce you to two people. This is Peter Rabbit and his friend Lily. And today I'm going to tell you the story, the tale of Peter Rabbit.
Yeah.
By Potter.
Peter Rabbit.
Once upon a time, there were 4 little rabbits, and their names were Flopsy, Mopsy, Cottontail, and Peter. They lived with their mother in a sandbank underneath the root of a very big fir tree.
So if you want me to send you the link for that, I can send it to you. Cool bedtime story with Grandma Newbold. So I thought that'd be pretty fun. It's a public domain book, which means that anybody can read that. And so helping today with 10.1 Solving in Exponential Form. And so this is something new they're having us do this year. So just gonna give you some basically some notes here. So some steps, if I could type. Steps for solving exponentials. Here we go. Exponentials. Woo! So some steps for solving exponentials. Here we go. Step number 1. Write this down on another piece of paper or memorize it. So step number 1 is to get both sides to have the same base. It's all about that base, no trouble. Woo! We're bringing exponentials back. So we got get the same base, which you can already see that 1, 2, and 4 already have the same base. But the other ones, it's going to have a different base. And so we'll describe to you how to do those, get the same base today. Step number 2 then, I guess if I'm teaching you correctly, this is the first time really we'd introduce logs, even though they probably didn't want me to show you this, but this is the right way to do it. You can basically cancel out both bases and bring exponents down. And so I mean technically that'd be step 3 technically. But step 2 would just be to log base the same number on both sides. And so for example, problem number 1, we'd log base 2, that gets rid of it, and then you bring down the negative 2r, bring down the 2r. And so yeah, so cancel both bases there. Awesome. And then finally step 3 would just be to go ahead and solve for the variable. So then, or step 4, sorry, would be to solve for the given variable. Cool. So let's give that a try and see if we can show you how to do that here. So I am using my mouse because I am at home right now. Whoa. Stay at home. Stay safe. Wash your hands. Happy birthday song twice. Cover up your mouth. Sneeze into your arm. All those cool things they're telling us to do. And now they're telling us to use a face mask when you go to the store and go out for your job, or if you have to go to the store. Those are the 2 vital things, I guess. Otherwise, stay home. So that's kind of crazy because I already started doing that because I knew to wear a face mask. You know, it's like, oh no, that won't stop you from getting of course it will. You're not breathing in anybody else's germs. Silly CDC. But I guess they just wanted to stop us from hoarding face masks like we did toilet paper. And so if you're watching this in a different year, just to let you know, it was crazy in 2020. Crazy. Okay, so starting with number 1, we're already set up. We've got both sides, the same base already. Check. So we can go ahead and log base the same number on both sides, and that'll help us cancel out both sides. So you don't necessarily have to do this, but just kind of know that's what's going on when we cancel out the bases. So you're basically going to log base 2, and so that's basically all that's going to do, is that's just going to go and eliminate the bases completely. So that's going to be step 3, which is just to cancel out both bases and bring the exponents down. So now we're going to bring down the negative 2r, and then bring down the other positive 2r. Now we just want to solve for r, right? And so when we go ahead and solve for r, we're going to want to get the 2's to the other side and r's all on the same side. So it doesn't really matter which side because both is going to work. But let's say we want to keep it positive. So then we'll add 2r to this side. That'll create 0 on that side. And then we'll add 2r on this side. I guess we don't really need that equal sign there. Okay, so then when we do that, that'll create a 0 on this side, right? Because a negative 2r and positive 2r is 0. And on this side, it'll be 2r plus 2r is 4r. Nice. So then we have 0 is equal to 4r. And again, we want to solve for r right now. And so then we want to get r by itself. Right now it's being multiplied to the 4 is being multiplied to the r. So we want to undo multiplication. And we want to go ahead and divide. Divide 4 to the other side. And so when we do that, that gives us r equals 0 divided by 4. And 0 divided by 4 is just 0. So then r equals 0. And so our answer to number 1 is just r equals 0. Awesome. There we go. So number 2, taking a look at that one next, just kind of jumping around. Maybe we'll let you try number 4 on your own. So again, we're basically just canceling out our bases by log base 5 both sides. We're not really supposed to teach you that yet because this is just 10.1. But that's the proper math that's going on here, is that you're logging it, and that's actually what cancels it out. And some of you really like to see proof on that. So we'll show you that here in a second. Pull up our calculator just to prove it to you, to know how we can just get rid of bases. While that's loading, now we just bring down the 2x plus 2. Don't worry, I covered up my mouth with my elbow. There we go. Okay, so we have 2x. Wow, it's not going to let me do it while it's loading. Yeah, look at that. Okay, so bring down the 2x plus 2 is equal to 2x. We want to get all the 2x's on one side. What the? Well, this is going to do something funny. So when we go to minus 2x to the other side and leave 2 on the left side, when we minus 2x there, that's going to become a 0. That's going to become a 0. What the? So we're going to end up with 2 equals 0. And so that's strange, huh? So 2 equals 0 is just doesn't exist. That's undefined. So number 2, the answer is going to be does not exist. There we go. Awesome. And so that's how you do number 2. Now let's just show you that log basing just to prove it to you, right? So we're about to do this part right here where we log base 2 base 2, okay? So just to prove it to you there, just to prove it to you. So we go ahead and do, I think it's under the math button if you have a super fancy calculator like this one. So you go to math button, and you go all the way down, 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 to option log base, which is A. Promise I'm not sick. I just had to do that because it's fun. No, I had a hot brew of the barley drink. No, it was, yeah, something like that. Anyways, just stuck in my throat. Need a regular drink of water. Okay, so log base. Here we go. Okay, so log base. All about that base. So if we log base 2, if something has a base of 2 to an exponent of, in that problem it was negative 2r.
So we won't say negative 2r, but we will just put a negative 2 there so you can see it. And cool. So then what's going to happen is the log base 2 is going to cancel out the base 2. Did you see that? Did you see that? Did you see that? Did you see it? Cool. So then we'll go and show that to you what just happened there. Awesome. So what happened is the log base 2 gets rid of the base 2, and then we're just left with the negative 2, which is the exponent, right? Because the base 2 got canceled out with the log base 2. And so when we log base 2, that gets rid of the base 2, do it to both sides, and then all you have left is the exponent, negative 2r equals 2r. And so that's what we did there. And so that just shows you why those cancel out, basically. Okay, so we'll let you try 3, 4, 5, 6. And so let's see here. Let's jump to number 7, because that looks kind of fun. Maybe we'll do 8 first, just because that's a little bit easier. Then we'll jump back to 7. And then we'll let you try a bunch on your own. So basically, what we got to do now is we're going to take a look. So step 1, we got to actually focus on that now, right? And so step 1 is getting the to get both sides to have the same base. And so all these bases, even though they look like crazy numbers, all these bases actually come down to just a basic number, a basic root, basically. So you'll want to factor these. And so, for example, 81 factors into 9 times 9, right? 9 times 9 is 81. And so that means this can be written as 9 squared, if you want. And then 243 is probably also a factor of 9, or if it's not a factor of 9, it's a factor of 3. So let's just take a look there. So 243, divide by 9, see if it's a factor of 9, which it is. So this factors into 9 times 27. Nice. So we don't have the same base number yet, so we are going to have to factor that 27 down more. And it also factors into 9 times 3. Good. And so now that means it factors into 9 and 9 and 3. Because of that 3, that means we're going to have to factor this more into a base of 3's. So problem number 8, you're going to have to bring it all the way down, factor, until basically it's bases of 3's to whatever power. And then we can solve it from there. Well, 9 factors into 3 times 3, and this 9 factors into 3 times 3, and so now we have a ton of 3's is what we're working on. This one, again, 9 squared factors into 9 times 9, and these 9's factor into 3 times 3 is 9, and this 3 times 3 is 9. Cool. Okay, so now we found our base. Our base is going to be 3 on both sides. And so how many 3's do I have? Well, I have 5 of them here. 1, 2, 3, 4, 5. And so this is going to factor into 5 of them. So we're going to do 3 to the 5th power. Okay? And so that's because it's 3 times 3 times 3 times 3 times 3, 3 to the 5th power. So that means that that's what this 243 breaks down into, okay, is 3 to the 5th power. But then also, you can't forget that you had 2v to the plus 3. And so 2v to the plus 3 is going to go next to that 5, okay? So now we have 2v to the plus 3, because that was the original exponent. And then 243 became 3 to the 5th power. So we can just put that 5 up there with the 2v plus 3. Then how many 3's do we have there? 1, 2, 3, 4. So 3 times 3 times 3 times 3. So that's going to be 3 to the 4th power. And so 3 to the 4th power goes there. And so that was the 81, right? Because 81 is the same as 3 to the 4th power. We'll double check it for you if you don't believe us. That's okay. Good to double check always. So 3 to the 4th power is 81, as you can see there. And so that worked. Cool. So now we have our problem. So now we've broken it down into something we can handle and deal with.
And so now, again, we're just going to cancel out those bases because that's back to, so we got number 1 done. And then number 2, log base the same number on both sides, log base. And so that's what we're about to do, and cancel out both bases and bring down the exponents and then solve for the given variable. So now we log base 3 and log base 3, both sides. We'll explain what log is in the future. But in this case, it's just going to basically just get rid of your bases. Is what we want to learn. And so we're going to do 5 times 2v plus 3 is equal to, and so that's just the 4 because the base 3 went away, and so we're just left with equal to 4. Equal to 4. Cool, so now we just want to solve for v, right? Solve for v. And so what we can do then is we could either distribute the 5 through if we wanted to, or we could just divide the 5 to the other side. I think we'll make it easier and just distribute it through. And so we're going to distribute that 5 through like that. And let's go ahead and show our work up here now with an arrow. And so 5 times 2 is 10. So we have 10v, good, plus, and then 5 times 3 is 15, there we go. So 10v plus 15, because 5 times 3 is 15, equals 4. And so now we just want to solve for, v. So let's go ahead and minus the 15 over to both sides. So what's a negative 15 and a positive 4? What do you think? Well, 15 minus 4 is 11, but it'll be a negative 11, right? Because the negative number is bigger. So it's going to be a negative 11. And then we have 10v is equal to negative 11. And it's being multiplied. So we want to solve for v, so we're just going to divide. So we'll divide that 10 to the other side. And that's what v equals. V equals negative 11 tenths. Awesome. So it's always good to double check our answers. So that was for number 8. And so number 8, we did get a negative 11 tenths. Beautiful. There we go. We're doing good. Okay, so that's how you do number 8. And then dealing with a fraction, make sure this video is not too long. Let's see where we're at. Whoa, 17 minutes. I guess we better end this one. And so come back and watch part 2, and we'll show you how to do the fraction ones. Right? So thanks for watching. Thanks for watching. You behind the screen, thanks for watching. Here I am. Whoa, thanks for watching. Haven't even done my hair yet. So thanks for watching. See you in the next video. Bye for now.